All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone.
Good morning, sir.
How are you today?
I'm good. How about you?
Good, thank you. Yeah, welcome, Miza. Welcome on the board. We're on the board now, going to final test. All right. Everybody must be ready. Tighten your seatbelt. We are going to fly. All right. Let's start with praying. Pray begins. Pray finish. All right, guys. As usual, could you please write down how many questions you solved last week? Because last week and this week is very important week before the final test. So I hope all of you have already solved more questions than usual. Uh, this is the final preparation weeks, so I think you should solve more questions. Let's see. All right. All right. Okay. Mirza, can you write? How many question? Prayoga Rido, are you here? Prayoga Rido. Rido, Denny, and Shauki, are you here? Rido, okay. Denny, are you here, Denny? Danny and Shauki, I think it's not here. They're not here, right? Any information from them? No? Okay. By the way, guys, there are some mistake in the weekly score. Okay, I just aware that there are some mistake because of the naming. So when you write the name, some of you, mostly the name that starting with Muhammad is mistaken in the order because some of you is writing only M, some of you is writing Muhammad, So that's why there is a changing in the order. So that's why there is a mistake in the score. I just realized from 10, 11A. Now in 11B, I don't know whether there are some mistake or not, but I took now here the score from the responses. Maybe they will be changing. I don't know. Maybe also not changing. All right. Okay. Let me hide this one. All right. Now I'm going to show you again the score. Please, Yogi. All right. This is the score. Alfie now, I think changing, yeah. Alfie, you got 100 now. Previously, last week, what you got?
Salah 2, benar 10, Mister.
So it is wrong, yeah, because the naming, I think the one with M is something wrong with starting with M. So for example here, yes, Naufal, Rido, Vishnu. Let me sort this by name. All right. Last week, who got 100 in this class?
Rido, Mirza.
Huh?
Rido.
Rido and Vishnu, yeah.
And Rido and Mirza.
Rido and Mirza. Vishnu, did you get 100 before?
Yes.
Okay, there's something wrong here. So this is the real result, yeah, because this is I get from the responses, not from the data that has been edited by the panitia. Because I told you that the data that edited by panitia, there is a change in the what we say order of the name. So in here there is no way to go wrong because this is taken from the responses. So what you respond, the score will be written here. So here now, here the one who get 100 is Alfie now. Okay, Alfie get 100, 12 to 12. And then Vishnu got also 100. Only 2 students in this class. Okay. Anything to say about this score? No? All right. If no, I'm going to stop sharing. Thank you for the one who got hundreds. All right. Now let's do some reflection and contemplation from last week lesson. Who want to make a contemplation and reflection? Please. Do you know where's Danny? Is he also joining AKM?
Chatnya centang 1, Mister.
Right.
Enggak nih masuk. Coba saya hubungi.
All right. Who want to say something about last lesson? Please. Prayoga, do you want to say something?
For the reflection, our lesson from yesterday is
Last week.
we learned about last week is chemical equilibrium.
Yes, chemical equilibrium. Yes. What is
The chemical equilibrium is a state of balance in which the rate of forward reaction equals the rate of the reverse reaction,
All right.
and the concentration of product and reactant remain unchanged.
All right. How to write the Kc, equilibrium constant?
What's it?
How to express the Kc?
Express the Kc. The Kc is the product divided by reactant.
All right. How about Kp?
K, the rate of Kp.
Yes.
The Kp is the rate of Kp is the
expression of Kp, not the rate.
expression. Can I write it in the comment section?
All right, please. Are you writing, Yoga?
This is the expression of Kp.
It is not Kp, it is Kf. My question is Kp.
Kp.
The expression of equilibrium constant in terms of pressure.
Pressure. Let's say.
Can answer my question? What is Kp? How we express Kp? Yes? Nobody remember what is Kp? Yes, Yoga. Mursid, please.
Pressure of product over pressure of reactant.
All right. Pressure of product over pressure of reactant. Very good. What is the relation between Kp and Kc?
It is written also in the yoga answer. So
Kc time RT delta N. Very good. Okay. Thank you, Mursid. Yoga, can you give your contemplation?
Wait a second.
How about you, Murshid? Can you tell us your contemplation?
Okay, excuse me. Let me use bahasa. So
Yeah.
my contemplation is, jadi kontemplasi saya, refleksi saya itu tentang sepeda.
Yes.
About wheel. So untuk menyeimbangkan sepeda kita harus berjalan, sama seperti chemical equilibrium kan, chemical equilibrium itu kan dinamik ya, dinamik yang artian dia itu harus moving to keep their balance. So sama juga seperti sepeda. Sepeda ini seperti kehidupan gitu loh. Sepeda tuh harus berjalan untuk bisa seimbang. Nah, sama relasi dari kehidupan itu juga begitu. Untuk kita menyeimbangkan keseimbangan kehidupan, kita harus jalan. Dalam artian keluar dari zona nyaman. Kita harus kita harus merasakan yang namanya kegagalan yang kalau di roda itu di bawah ataupun di atas yang namanya kesuksesan. Jadi menurut saya ya kontemplasinya seperti sepeda.
All right, thank you.
Biar
Life is like a bicycle. You have to ride your bicycle continuously move, push on your pedal to balance your life. If you're not doing that one, then you will fall down. And without continuing, you will not learn, because when you are moving, you will learn that your effort, whether you are fail or you are not fail, you are win something, you get something. All of them will be learned when you are moving dynamically. Without movement, then you are like a dead man. You are like a corpse, yeah. People or person have a ruh, yeah, have a inert, what we call that one, the one that's inside yourself. So it is always moving. If it's not moving, then it will be dangerous for you. Something which is not moving always be dangerous. So that's why you have to move like chemical equilibrium, that always be moving, nothing, not stopping, always moving forward and backward sometime, but the most important thing, you continuously move. Okay, thank you. Murshid got 1 point for this. All right, this session we are going to continue to discuss about equilibrium. All right. So in the extra lesson, compulsory extra lesson, we did some of the thing. We talk about the variation of the Kc. Do you remember the variation of Kc here? If we reverse the reaction, then the Kc will be the reciprocal 1 over Kc. Right? This is the first one. The second one here, if you multiply the reaction by the factor, then the factor will be the power of the new Kc. Yeah. And the last one, if you sum individual reaction in the reaction, so the total overall Kc will be the multiplication of each individual Kc of the reaction. This is what we learn in variation of Kc. Okay. And today we are going to continue to discuss about the factors affecting equilibrium. This is the last topic. Hopefully we're going to finish it today, all the topics. So next lesson we're going to focus on solving questions. All right, here, let's discuss a little bit. What things that will affect the equilibrium? What do you think? Say something.
Concentration.
Concentration, very good. What else?
Temperature.
Temperature, good.
Pressure.
Pressure, very good. What else?
Color.
What? Sorry?
Yeah.
Volume.
Volume.
All right.
Color.
volume. Color, you see? Color? What color? What do you mean color?
The like reaction changing, the effect of reaction.
I don't think so, the color. Color will not affect it. We are not reaction. We are not talking about reaction. We are talking about equilibrium. All right, now, okay, let's keep this one. Now, when we are talking about the rate of the reaction, you remember, when I say something that affect the rate of the reaction, it's mean that the reaction can be faster or slower, isn't it? For example, if I changing the temperature, if I increase the temperature, the rate of the reaction will become faster. When I decrease the temperature, the rate of the reaction will become slower. So there is an indication there, indicator, which is faster and slower as the indicator of the effect, right? In equilibrium, what indicator we can use? Can we say that equilibrium will become faster or slower or anything else? What do you think?
I think the equilibrium constant.
Equilibrium constant, you mean the equilibrium constant will increase or decrease? Right, it can be.
Yes, sir.
It can be, but not really it is. Any other opinion? Let's write here, equilibrium constant also, yes, it will be, it can be as the indicator.
Time needed, it gets to equilibrium.
You mean faster and slower?
Yeah. Not really.
Yes, it can be, but not really. It's like Casey. Okay, faster and slower. Let's see. What else? What else can be the indicator of the effect of the equilibrium? I mean, when you do something to the equilibrium, what will the effect? Okay, for example, if I have a reaction here, there is a reactant and product in the equilibrium. Reactant and product in the equilibrium. Right. What can we say? When I increase this temperature, or when I add the concentration, when I add the pressure, what can I use the indicator to showing you the effect? Okay, now look at this. Let's use the analogy of balance. Let's say that we have a balance like this. All right, it is in balance, which is in equilibrium. Let's say it is in equilibrium balance. When I disturb this balance, what will happen?
Fall.
It will moving, right? Like this.
Yeah.
Yeah. So in the reaction, what is this? It will be shifting either to forward or to the reverse, isn't it? If the balance is moving like this, moving back and forward, up and down, in the reaction, it will moving shift. We call it a shifting to the product or shifting to the reactant. Yeah, shifting to the product or shifting to the reactant. So the effect in here we call as a shift. The effect of the equilibrium can be indicated by shifting. Either it is shifting toward the, all right, now it's very toward the product, or the first one toward the product, or it is shifting toward reactant. So there are two possibility. Either it is shifting toward the product or shifting toward the reactant. So it's changing like this. In balance is up and down, up and down, up and down. In reaction, it is forward, reverse, forward, reverse, forward, reverse to the product and to the reactant. Okay. So we are going to talk like this. If I changing the temperature, the equilibrium will shift to the forward or to the product or shift to the reactant, to the reverse. This is what indicator that we will use. Okay? Is it clear? Right. If it's clear, let's start with this one. Okay, the principle of affecting the equilibrium is used, the principle used for affecting the equilibrium is Le Chatelier principle. We call that one. Le Chatelier is coming from French scientist. This guy's named Chatelier. So this principle is taken from his name, Le Chatelier's principle. What Le Chatelier principle say? Le Chatelier principle say that if we have a chemical system at the equilibrium, so let's think about we have a chemical system at equilibrium. Let's think about we have a balance that already equilibrium. When you disturb that equilibrium, what will happen? The system will counteract. This one is important. The system will counteract the changing by doing what? By doing shifting. Like I said, doing shifting for what? For re-establish a new equilibrium. So if you have a balance, when you disturb the balance, it will shifting and then it will form a new equilibrium. The same thing like the reaction. When you have an equilibrium reaction, you disturb that reaction, what will happen? It will be shifting forward and reverse, forward or reverse, and then it will form or establish a new equilibrium. So the system will be counter-strike. Sorry, not counter-strike. It's your games. It's counteract, not counter-strike. Counteract the changing. Yeah. So if you give disturbance, then the system will counteract the disturbance and it will establish a new equilibrium. All right. Is it clear? This principle. Okay, you can write this one in your notebook. The principle is very important. All the things that we learn in the effect will be based on this principle. All right, finish? Do you have any question for this?
Saya mau nanya,
Yes, please.
the meaning of counteract itu apa?
Melawan.
Jadi ya itu misalkan kayak suatu equilibrium itu diganggu oleh konsentrasi lah. Itu berarti nanti equilibriumnya itu akan dirusak oleh konsentrasi itu.
Yes, but the system will counteract to make a new equilibrium.
Hasilnya itu nanti equilibriumnya itu baru lagi ya, nggak
Yes.
yang equilibrium.
Yes, after the disturbance, the system will counteract and they will make a new equilibrium. Okay?
Gitu.
Can I ask a question, sir?
Yes, please.
What does make a new equilibrium mean here?
For example, if you add concentration, of course, the new the old equilibrium will not happen at the same condition because you add concentration. For example, if you have reactant and product, it is at equilibrium. You add the reactant. Is it will stay at equilibrium? Like, for example, you have a balance. It is in balance, yeah. The left and the right, it is in balance. And you add something to the left. Is it make sense that the equilibrium will not be changing?
No, I think.
Of course, it will be changing, right?
Yes.
Something like that. So something like this. Think about if you have a balance. The same thing here. If you have a balance here, it is, for example, it is in equilibrium already. For example, you have something here 4. This is 4. It is in equilibrium. But I add here, I disturb. I add 2 more here. It is will be the same equilibrium, the condition. Of course not, yeah. It will counteract first. I mean the counteract, there will be shifting. And then after that, new equilibrium will establish. The concentration will be changing, product and reactant. The first equilibrium and new equilibrium will be different, the concentration. This is for concentration, yeah, we are talking only concentration, but not only concentration. Let me say that not only concentration will affect the equilibrium, pressure also will affect, temperature also will affect, and any other things. But the easiest way to understand is you make that analogy with the concentration. If I add the reactant, then of course the new equilibrium will establish, and the concentration of the product and reactant at equilibrium will be changing, isn't it? Okay. Any other question? All right. If there's no other question, let's continue. Now the first one, we are going to talk about concentration. This is the easiest one, like this, yeah, like this example. Okay. For example, if I add this ammonia, ammonia is in the right here. I add the ammonia. What do you think? The equilibrium will shift to which part? To the product or to the reactant?
Reaktan.
Right? Because when I add ammonia, now the amount of ammonia is increasing, right? The amount of ammonia increasing. In order to make it balance again, it must be shifted to the reactant. Betul? Yeah. If I add the product here, the ammonia is the product, then the equilibrium is disturbed. And what happened to make a new equilibrium? This excess amount of ammonia, because of the addition here, excess amount of ammonia must be balanced or equalized by shifting shifting the equilibrium to the reactant. Okay, is it clear? All right. So the same thing, if I add the reactant, any reactant here, for example, if I add nitrogen, then the reaction will shift to the product. If I add hydrogen also, the reactant will shift to the product because nitrogen and hydrogen is in the reactant. Overall, we can say that like this, when I increase the concentration of product, I add here, increase in adding concentration of product, it will shift to the left. If the product, it will shift to the left. When I increase the third one, look at the third one, where I increase the concentration of reactant, then the equilibrium will shift to the right. And for decreasing is the reverse. Here, for example, I'm not adding NH3, but I decrease the NH3. Saya kurangi NH3-nya. I decrease the NH3. What will happen? The reaction will shift to which side? Product or reactant? If I decrease this one, if I decrease NH3, then the reaction will shift to the product because NH3 now have less amount because it is decreased. Then in order to make a new equilibrium, then the reactant will fill the less amount of ammonia in the product, then it still goes to the product. The same time, when you decrease the reactant, then to fill out the gap that you decrease it in the reactant, then the equilibrium will shift to the reactant. Okay, so when you decrease the product, the equilibrium will shift to the product. When you decrease the reactant, the equilibrium will shift to the left. But this is important thing, guys. Shifting the equilibrium because of the concentration is not changing the K value. It is only changing the concentration. It is only changing the concentration of the reactant or product. Depends on the condition, depends on which part will be shifting. But K value will stay constant. This is important. K will be constant. It means no changing in K. Clear? Okay, you can write this one in your notebook and then we're going to continue. I think we have under 1 minute now. After you finish writing, then let's have a break. And then we're going to continue after the break.